Good afternoon. My name is Chuck Weiner. I'm presenting this remotely with Professor Barbara Nicolai. We're both from Purdue University Calumet, which is, if you will, Indiana, but a suburb of Chicago, about 20 miles southeast of the city. And we're very pleased to be able to bring you what we feel is a solution to unfortunate issues, whether they're man-made or natural disasters, that need a solution in as quickly as fashion as possible. So this is our work that Barbara has been doing as the PI. I'm just one of the co-PIs on this project, and it's happened since the Katrina catastrophe, and Barbara was, I guess, involved to a point where she thought there must be a better way, and based on her systems and database background, allows for some solutions that she's been able to implement. This is a prototype system that we're going to show you at the end of these slide presentations, so you'll be able to see literally how some of this works. It's all web-based, so it can be mobile device incorporated as well. The goals of the project are, one, to develop this as a web-based disaster management communication system, enabling resources and equipment in order to be better and quickly sent to those areas where they might most benefit the people who are in the disaster itself. In addition, we want to make sure that the information is going to be assessed as quickly as possible and get the data so that we can have the resources sent to the particular locations as quickly and as efficiently as possible. In order to do that, we use the high-performance computer, the supercomputer at the university, our Purdue Calumet campus, and get the results of that, and then use 3D or 2D solutions to look at the best way in order to have the resources moved to the appropriate locations in order to help those who are in the disaster. One of the abilities that we have within the campus itself is using a cave, which allows us to have virtual reality desktop or cave itself in order to be able to see, again, graphically and visually, how to best take these resources once they're identified, where they're needed, and then get them to those disaster locations as quickly as possible. What we're going to be showing today is the resource ordering and equipment tracking module that Professor Nicolai has been working with her graduate and undergraduate students to develop. And then the resource route optimization is the algorithms that have been used by Professor Jin, who is using the high-performance computer to input the data, and then in a matter of minutes rather than days, getting the results out so that we can chart that in 3D or 2D fashion. This is a simplistic overview, graphically representing what we expect and how it's going to work. We have requests coming in from people in the field. Those are either being done through laptops, smartphones, other types of mobile devices. Once that information is entered via the web-based system, the disaster management communication system, then that information is uploaded to the HPC, the high-performance computer called the Peregrine 1 at our Purdue Calumet campus. That information is then massaged, results given to us through the disaster management visualization system, through our Center for Information through Visualization and Simulation, commonly referred to as CIVIS, C-I-V-S. And then the decision maker's workstation at the command center would be the ones that would be identifying the best way using that information to get help where it's most needed. This is a typical scenario that happened in real life in terms of a flood within the northwest Indiana community known as Munster, Indiana. It was more than just this one community. However, this community is one that we're using to show a different timeline of activities. At 3 in the morning there was a flood watch issued, and that information, which we'll see in just a moment, was sent out to mobile devices so that those individuals who have a mobile device would receive a warning. At 12:30 the flood warning was issued. You'll see that as an alert on a phone in just a moment. At 4:30 a command center was established. That'll be location 1. You're going to see that through a Google Earth solution that we have with an API on this system. At 5 o'clock the command center orders various resources into the area. In this case you'll see how we order sand, bags, shovels, people, as well as generators and pumps in order to help resolve the problem with the flood itself, those individuals in the area itself. And then around 6 o'clock you'll see that requests from residences would come in, and those can be entered again through their either smartphone, or if they still have power, they could make use of their laptops or desktop computers. This is the alert that would be sent to the individuals who have recorded and referenced this, so that you can see that these 2 messages have come about, and one of them at 1:30 and then another one again at 3:30 p.m. This was scheduled as of the issue itself, which was on June 20th. This particular slide shows an area which has the flood involved. That would be the purple area. So there's a residential community, there's a major highway in the area, and in just a moment or two after we get through with the slideshow presentation, I'm going to activate the video that we have, which identifies how information would be entered into the system, and then how that information is going to be used in order to send resources to the appropriate areas within this flooded area. Obviously the area outside of this is where the locations are where the resources would be stored, and then it's necessary to, in a most efficient way, bring those resources to the aid of those individuals within the flooded area. This is going to be a video at the end of this presentation that's going to show first the flood itself, the area growing. Right now it shows the green area highlighted within the latitude, longitude that would identify the space where the flood is. You're going to see it with the video where it's growing because the floodwaters are getting larger and encompassing more of an area. And then you'll see how we use the high-performance computer to input the data and wind up being able to have the resources sent to the appropriate location via the command center itself. The system itself uses the Google Earth engine in order to enable people that would be interfacing with the system to be using a system that they're comfortable with, because Google Earth has the tools and the buttons and the arrows and the devices that would be familiar to someone, whether they're using it in a personal or, in this case, perhaps a governmental type of environment. So it's blending either 2D and or 3D as well as text elements and pictures that can be uploaded specifically where the latitude, longitude would show there needs to be information available for others to view. And again, you'll see that in just a moment. Here's an example of someone looking at a particular flooded area, taking a video of it on their smartphone. The system would then upload that information. It would be stored inside the server itself and then automatically placed and or updated into the appropriate exact location where that picture was taken, again based on latitude, longitude requirements and numbers that come in from that site using the GPS of the mobile device itself, in this case a smartphone. This again shows the exact location of the flood zone. You can see that in this case it's a bit larger area. The flood is now encompassing a greater percentage of the area that will ultimately be necessary to be assisted through the flood itself, bringing resources to bear so that the resulting individuals and businesses in the area can better be served and hopefully get the solution to this in terms of draining it and making available the sandbags and other sources in order to minimize the negative effect of the flood. The optimization of the distribution routes is computed based on the high-performance computer system itself. And again, this is what we refer to as our Peregrine 1 supercomputer on our Purdue University Calumet campus. There could be multiple routes from the command center to the distribution sites itself, and the generation of graphic images will aid us through the graphic information system in order to make the most efficient routing of those resources to the locations where they're needed. So the vehicle routing problem is constructed to use a minimum set of costing of routes that meet the customer demand and minimizing the total distance of transition routes, which basically just means how can we get the resources where they're most needed in the shortest time frame and the most efficient way. This is an example showing on the far left upper quadrant the beginning of the flood, the far right upper quadrant showing the flood expanding in area, the bottom left quadrant showing again additional flooded area, and the bottom right quadrant showing again additional locations that have been flooded. Connecting the high-performance computer system and visualization allows us to automatically upload to the Google Earth-based 3D visualization system that's hosted by our Center for Information Visualization through Simulation, which is the CIVIS Center at our Purdue University campus. This approach is going to enable the users to immediately see the computational results from the web-based 3D visualization center. Now this could be using the cave, which is part of our theater at the Purdue University Calumet Civic Center, or using a 2D system rather than the 3D visualization. The end result is the same because it's going to enable us to graphically see the best way to be able to get those resources where they're actually needed. When the disaster actually occurs, we're going to say, well, what would a particular municipality or government agency need in order to use the system itself? And Professor Nikolai, in just a few moments, I'm going to put her on, and she'll be able to talk more specifically about this. But essentially, it's scalable. It's going to be able to be used from a local municipality, a city, a township, a county, throughout the state level. It's something that we could use from a single server located specifically in the area or near the area where the disaster might occur. Could be in a trailer of some sort that would be a mobile device that would hold and incorporate all of the necessary communication equipment and computer equipment that would be necessary to support the solution of this using the disaster management communication system. And we're testing it for large population areas, and assigning IDs and basic training is something that would also be required. The disaster itself is going to be identified in terms of the scope of it and where it's located by 8 north, south, east, and west latitude, longitude coordinates. This is going to be used in order to interface with Google Maps, and we would be able, hopefully, to have all of the available equipment pre-registered from other government agencies that would be sharing the equipment in the disaster, or private corporations that would make available their particular resources, whether they're pumps, or other types of devices that might be used within a flood, or it could be some heavy-duty equipment for construction that we might be able to make use of to aid in the disaster solution. The people who have been involved in this particular project are several. The main person is Professor Barbara Nicolai. She's a university professor within our Computer Information Technology and Graphics Department. We have Professor Gerjin, who's also an assistant professor within our CITG, Computer Information Technology and Graphics Department. Myself as well, Chuck Weiner. And then we have Mark Kaposius, who's a graduate of our department, also a graduate of our Master of Science program in Technology. James Miller. Jim is one of our CIT undergraduate students who is now going to be one of our master students, MS student. Dustin Franz is also a computer technology student through the College of Technology. Hector Alvarez is also a graduate of our program. And Jerry Decker is a computer science, master of science graduate, also working with the CIVIS staff. What's amazing is the involvement that Barbara has had with many, many of her students. And as this slide shows, we have 415 students and more as each semester progresses that are both undergraduate and graduate students within our Computer Information Technology department. That program, Computer Information Technology, is supporting Barbara through the students that she's able to make use of through a experiential learning course that we offer, where students must take 2 experiential learning courses before they graduate from the university. And this is one course that satisfies that particular need as experiential learning. It's real life issues, not just book work, not just lab work that we have, which is of course meaningful, but this is a real situation. The disasters have happened. Unfortunately, they continue to happen. And Barbara and her team are looking for solutions to that. So what I want to do now is, before I turn on the videos that we have, I'd like to bring Barbara into this discussion so that she can identify and add to what we've already talked about. Barbara, if you're there, please go ahead.
Yes, can you hear me?
Yes. Go ahead.
Actually, this has been my passion since Hurricane Katrina, because there was such a desperate feeling of helplessness, and so I figured what better way than to use everything that I've learned and share it with within the classroom setting. What has been very rewarding and amazing to me is that we have so many students, once they understand that they can make a difference with what they're learning, their enthusiasm has just been overwhelming. I have students, graduate students, who have graduated out of the program who stay with the research pro bono. And I have, right now I have 3 graduated master students who continue to work with me on this project. Other than that, I think I'm going to stop talking and turn off my talk button and entertain any questions.
Okay. The one thing that I do want to stress on this is that as part of the experiential learning that students receive through this particular course, and they can take it twice based on the requirements and the need that's obviously there through this project, is that Barbara and her team, several of these undergraduate students and a couple of the graduate students, have developed and prepared papers that have been presented at national conferences. Barbara is also in the process of going down to our state of Indianapolis capital and presenting this project and a prototype that she and her team have developed to the state so that hopefully Homeland Security will see the value of it and allow her to continue with resources that would be financial in order to continue having students work on the project and get it to a point where, in fact, we can implement it rather than, at this point, making the prototype version. So what I'd like to do now is bring up the document that has, let's see, what it'll be here. And what I want to do is start this up so you can see how the system actually functions.
So this is correct in Northwest Indiana. The first thing we're going to need to do is associate the nearest call center with that disaster. So when we search by disaster, it's display that disaster on the map. Monster flood. We can go ahead and we see the flood right here, the flood zone. Let's go ahead and display all call centers by clicking display call centers. And let's go ahead and search. In a 75-mile radius, out of the center of this disaster, we have found one call center right here. And this will be the call center that we will be referencing throughout these orders that we will be placing. Next, let's go ahead and display all resources just to get used to the map. Pick non-FEMA and FEMA. Alright, you can see that we have 3 different locations and resources. And we have well over 1,000 resources to reference. What the Resource Support and Tracking System for Homeland Security has provided us is a means to look up FEMA reimbursable equipment at specific vendor sites. As you can see, each one of these holds many items. By clicking, we reveal every single resource in that area. Some are larger than others, as you can tell. And just by clicking on this icon, we could actually bring up any one of those. Now let's go ahead and display all warehouses and mobile units. Alright, these are all the warehouses and the mobile units, given the 75-mile radius out of the center of the disaster. This is a very useful tool for the user to actually look up information regarding warehouses, call centers, mobile units, and resources. Next, we'll be diving into admin order, followed by call-in orders from both a client and a warehouse. So let's dive right into it. Alright, what this is an admin order. With an admin order, we completely skip the preliminary step of a call-in order and go straight to finalizing. So let's jump right into that. A warehouse is requesting an admin order for 2 trucks, 1,500 sand bags, 1,000 tons of sand, 50 shovels, and a 15,000-gallon water tank. Now first let's look at the truck. We can see that we have 7 at this location. Let's go ahead and assign 2. And so here's that. You can see that item right here. Next, we're going to actually assign the warehouse that this is going to be shipped to. You can see over here that we have our full order that we implemented. And now we're going to actually search for the warehouse. So let's go ahead and do that. Let's search 75 miles out of our current location. And here we got some hits. We're actually going to send this to ourselves at the City Center. And there you go. The City Center has been selected. If you scroll to the bottom, we can assign the location. This right here is the email that both the shipping and receiving warehouses will both get. Now, at the time of placing the final order, this is shipped out straight to them via email. It displays not just the order, but where it's coming from and where it's going to, and also the command center that the order has been placed at. Next up, we're going to be creating 2 separate call-in orders, one from a client and another from a warehouse. A call center order is when a client calls into the call center requesting items, and the user on the phone quickly jots down the exact items that they need later to finalize the order when they have time. Let's go ahead with the client order. Let's find the client that's requesting. James Miller is his name. Let's search for him. This is a level 1 priority. It's not very bad. Let's let's go ahead and ask him what he wants. He says he wants 100 bottles of water. And also 2 generators. Alright, by clicking place a request index, you can see that the items are down here. Now, what's next is we just save the order, later we go back and finalize it. Next, we'll be going over the only difference that distinguishes a warehouse order from a client order, and that is a reference. That reference is to a warehouse instead of a client. So we would actually choose the warehouse when we go through this. Now, after both the client and the warehouse have called in, and we have the rate to actually go back and finalize these orders. First, we're going to start up with the client. You can see that our last client is right at the bottom, James Miller. Let's go ahead and click him. At the bottom, we can see the preliminary that references the exact resources that this individual requested by word of mouth. Next, we're going to find these resources in the database. Now that we've chosen our resources to place in that order, next we need to find a mobile unit to ship the package. So let's go ahead and do that. Right here, we can search for a mobile unit. Click display mobile units followed by search. Alright, we found a couple of 75 miles out. Let's go ahead and zoom in. We can see that the order is here now, along with the address of the client and the nearest mobile unit. Let's go ahead and drag and drop that to the nearest mobile unit. You can see that it's been selected. Clicking OK and create final invoice. Okay, here we see the preliminary invoice. And down here is actually the final. Next, we're going to be moving on to the warehouse orders. So same exact concept. You can view the preliminary invoice at the bottom. They're going to want 30 generators and 30 pumps. That's what we're going to be looking for. This is shipping to Munster Public Works, and you can see the quantity along with the item description. Alright, as a quick review for our scenarios with both the client and the warehouse, we'll go ahead and review those orders. First was from Barbara Nikolai. She called in and requested 5 blankets, 150 bottles of water, and 75 K rations. This order has been placed, looked up in the database, and assigned. It is also being shipped to her currently at this moment. Next, with the same scenario, James Miller, he ordered 100 bottles of water and 2 generators. This is also en route to his location. Alright, as for our warehouse resources, we can see that we are shipping to the Civis Command Center 2 trucks, 1,500 sandbags, 1,000 pounds of sand, 50 shovels, and 1,500 gallon water tank. Also, we're shipping to the Munster Public Works 30 generators and 30 pumps. These 2 orders are in relation to a flood disaster and will help cap off this disaster ASAP. This has been the Resource Equipment Tracking System module updates from DMCS. Have a great day.
Okay, in addition to that particular slide, I'd like to add the fact that because this is an experiential learning course, the students that are in the class that Barbara is working with these students wind up designing, developing, testing, creating the database itself, all the tables, all the relations, and coming up with the design of the entire system, including the infrastructure. So it is a total project. And the fact is, they are learning real-life situational learning needs that are going to be able to benefit them, and with this particular system, benefiting the individuals who unfortunately might be in such a disaster. This is just one example of a disaster, which happens to be a flood, but this would work with, unfortunately, any other type of disaster that would come about as well, whether it's an earthquake, as we don't have one fortunately in California, but God knows there have been too many already, as well as other types of disasters such as forest fires and other types of disasters that might come along. This is an example coming up, the last one, of how we can use the high-performance Peregrine computer system in order to identify how to get the resources in the most efficient manner to the location where they're needed.
No, they don't.
The DMCS system also features the ability to dynamically update distribution sites and routes. Here, we see rising water levels blocking off certain distribution sites and delivery routes are adjusted according to the optimized delivery time. The Google Earth API has been used to enable demo on the left side of the screen. The standard Google Earth controls are used for zooming, panning, and navigating through the and the database is updated. The events are automatically added in the Google Earth interface. Here we see in the left panel that the stat requests come in for flood-related resources. When events are selected, we are transported to the relevant location, and detailed descriptions are displayed along the bottom of the screen. Icons on screen identify other event information. Another feature of the DMCS system is the ability for people in the field to take pictures and upload tag information to the server. This can be done simply from mobile device.
Winding down, huh? Almost done? Pretty soon. Yeah. So the features that we've just seen in terms of the video are captured and developed through our Center for Innovation through Visualization and Simulation by Jack Moreland and Jerry, who have worked with Barbara and her team in order to take the output from the high-performance computer and put it into the graphical mode that we see on the screen and that was demonstrated just a moment ago. With that, we end our presentation, and thank you for your participation. Barbara, do you have anything you'd like to add at the end?
No, just thank you for your time, and if you have any questions or interest, Professor Weiner will give you my contact information. I'd be glad to talk with you or email you.
Very good. And that would be B. Nicolai, Nicolai, at Purdue, PURDUECAL.edu. That's B. Nicolai at PurdueCal.edu. My email address is Weiner, W-I-N-E-R, at PurdueCal, PURDUECAL.edu. Thank you very much.